All right, so sorry about the little delay that my computer is showing weird things to me. So we are going to try and share this. Having some issues with this today. All right, so here we are in chapter 13. I have no idea how much lag I had in there. So we've got chapter 13, which entails things in geometry. We're going to be talking about linear today. Okay, so we're going to talk about your different types of measurements, converting measurements, which is the trickiest part of this section. A little bit of dimensional analysis, perimeter circumference, and at some point some similar figures possibility. All right, so what are our different units that we deal with? Okay, so in our different units that we deal with, here in English system is we have yards, feet, and miles. Okay, so there are 3 feet in a yard. You should know that. You should know there are 12 inches in a foot, which would mean there are 36 inches in a yard. Okay, one thing you might want to write down is how many yards and feet are in a mile. Okay, 5,280 feet are in a mile, which if you want to multiply that by 12, you would get how many inches in a mile. Okay, so if we want to convert 5.25 miles to yards, this 1 mile is this many feet. Okay, or 1 foot is 1/3 of a yard. Okay, so if I have 5 miles and we go to yards, I can convert it to feet first, which would be easier to do because we know how many feet in a mile. So then you would get multiply the number of miles times feet, and then multiply that number by how many, 1/3 of a yard, or divide by 3 to get how many yards you get. Okay, so multiply the miles times feet and then divide it by 1/3. Or actually, not by 1/3. You would multiply by 1/3, divide by 3, because there's 3 feet in a yard. All right. Dimensional analysis, which means the process to convert one unit of measurement to another. Okay, the process uses unit ratios, which you have to know your unit ratios. Okay, now the same idea is that we're talking about. Let's go back here. All right, so what happens is, let's get to my little thing here. So when you take the miles times how many feet in a mile times yards per foot or feet per yards, okay, the miles actually cancels each other out is what this is saying. The feet cancels it out and you're left with just yards. Okay, and that's how your analysis going from one unit to another gets you to your yards. Okay. All right, so let's get to the next one. All right, so if a cheetah is clocked at 60 miles per hour, what is its feet per hour? All right, so we know how many feet there are in a mile. So we would go 60 miles per hour, okay, times how many feet in a mile. That means the miles are going to cancel each other out. Now I have feet over hours. It's 1 hour is 60 minutes. So, and then 1 minute is 60 seconds. Remember, we're trying to get to seconds, feet per second. So I have my feet now. Now, how do I get these canceled out? 1 hour over 60 minutes. So those would cancel each other out. And the minutes cancel each other out, which leaves you with feet over seconds. Okay? So you take your 60 times how many feet in a mile times 1 hour is 60 minutes, and 1 minute is 60 seconds. And that's how you work your way through it. Again, it's the most annoying part of this section. Metric system. Okay, so as we talk about metric system, okay, we talk about these prefixes. Okay, so we have kilos, or kilometers, if we would, what is your K? Hecto is 10, deca is DA, deci is D, centi is C, milli is M. These all work for almost any other type of units that we deal with. Okay, these letters. Okay, not just linear, but other types. Now the difference is your units, you're going to have units right here, like a meter. Okay, 1 meter. Okay, and then you have a decimeter as a part of a meter. A decameter is multiple meters. A hectometer is a lot of meters. A kilometer or kilometer is 1,000 meters. Okay, so as you go up, we multiply. But the centi and the milli is very, very little small pieces. There's 100 centimeters in a meter. There's 1,000 millimeters in a meter. Now, the thing about these is these are all factors of 10. This is 10 to the first. This is 10 to the second. This is 10 to the third. This is 10 to the -1. This is 10 to the -2. And this is 10 to the -3. Well, your meters is 10 to the 0, which is 1. Okay? So that's how all that kind of goes into play. So your base unit here is meters. Okay, so there's 10 meters in a decameter. There's 100 meters in a hectometer, 1,000 meters in kilometer, and so forth. So if I have a meter and I want to know how many kilometers is in there, I'm going to divide it by however many tens of zeros. Okay, if I'm going down, I'm going to multiply by numbers of 10 powers. Okay, and we'll kind of do one for you. Now you have some, where they come from, a meter is from shoulder to your tip of your finger, basically. A decameter is the width of your hand. A centimeter is only the width of your finger. Okay, not quite an inch. And a millimeter is just the width of that little part of the paperclip, very small. Now, converting. This is your base, okay? And your base is always 10 to the 0 or 1, okay? As I go down, you have fewer of these. These are smaller. So as you go down, you get smaller. So as you go up, you get bigger, okay? But it takes more of your base units of these, okay? It takes less of these. This would, like if this is a meter, 1 meter, this would be 1 meter would be 10 decimeters, or 100 centimeters, or 1,000 millimeters. Okay, up here you would have 1/10 of a meter. This would be 100th of a meter, and this would be 1,000th of a. Okay, so oops. All right, so how do we transition? Okay, well, if you think about this, okay, here is meter, and then you have decameter, hectometer, and kilometer. Okay, so if 1 meter is there, I want to go from kilometers to meters. That means for every step down, I'm going to multiply this answer by however many tens that is. That's 1/10, 2/10, 3/10, or 10 to the third, which is 1,000. So this is going to be 14,000 meters. 1,400 meters, sorry. Okay, if I start from the bottom, however, if I start below it, okay, millimeters is down here. You have millimeters, you have centimeters, and you have decimeters. There are 3 levels here. Okay, 1, 2, 3. To get up to 3 levels, okay, we're going to divide by 10 to the, it's 1, 2, 3 levels. Okay, so if I'm getting bigger, okay, it's going to be dividing by 10 to that, which essentially is going to take this decimal and move it to the left 3 places. And you get 0.285. Okay, so if you think about it, this, we move it, if we get into a bigger unit, you're going to move the decimal over to the left. But if you're going from a big unit to a smaller unit, you move the decimal over to the right. 1, 2, 3. So kilometer to centimeter is from here to here, which means if I'm going down, we're going to move the decimal to the right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we end up with 3,000. 0 and 0. Okay. All right. So does that make sense? So it's 1, 2, 3, 4, 5. 1, 2, which got it here, and then 3 more spots. So it's 1, 2, 3. So it's a 3,000. All right. Let me erase all that. All right. The distance between, off that topic now, the distance between any 2 points A and B is greater than the distance or equal to 0. Written, A to B has to be bigger than or equal to 0. Okay, so making sense, if I have some sort of distance between here, it's got to be bigger than 0. That distance could be 0, points A and B could be the same, but distance has to be positive. Okay. Second one, the distance between any 2 points A and B is the same distance from B to A. Written, A to B is B to A. So the distance of AB is the same as distance of BA, same length. Okay. And for any 3 points A, B, and C, the distance between A and B plus the distance between B and C is going to be greater than the distance between A and C, or equal to. Okay, so if I give you 2 distances and they have a common point, they have a common point of B right here, common endpoint, that means this distance has to be greater than or bigger than or equal to that other distance AC. All right. The sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. We've kind of already talked about this, but any 2 sides of a triangle, if you add them up, it better be bigger than the third side. That's all that's saying. Okay? We talked about that once before. Can a triangle be made with the sides 15, 18, and 37? Okay, so what they want us to know is, how do I determine this? Can you have, let's say, a 15, an 18, and a 37. Well, by this rule, the two smaller sides have to be add up to be greater than the bigger side. So if I make this 15 plus 18, it has to be greater than 37. Well, these two here add up to 33. And 33 is not greater than 37. So by that rule, that answer is a no. Okay. All right. Perimeter. You guys remember perimeter. You are adding, it's the length of a simple closed figure. To find perimeter, you have to have a closed figure or the sum of the lengths of the sides of the polygon. Okay, so I can find perimeter by adding up all the sides of a polygon. Here's a polygon, add up all the sides. 3 plus 3 plus 3 is 9. That is 9 centimeters. Add up these sides. L plus L is 2L. W plus W is 2W. I get 2L plus 2W. How about this one? S plus S plus S is 4S. Not a problem, right? That seems simple. What we do have to be careful of is this, and these are centimeters. Okay? Easier to stay with multiplication. And remember, centimeters, and then it goes down to millimeters. There are a bunch of millimeters. There's 10 millimeters in a centimeter. So it's easier to change all of these to millimeters by just multiplying by 10. So this would be 30 millimeters. This would be 10 millimeters. And this is also 30 millimeters. So then I have 10 plus 30 plus 30, that's 70. 40 is 110, that's 170. So that would be 170 millimeters. Okay, which could be also known as 17 centimeters. Okay. Now, what would be the perimeter of a regular n-gon side? Okay, well, n-gon side means it has n number of sides. It has s sides, which would mean it would be whatever n times s is. All right, so how about circumference? Circumference is the distance around the circle. It is the distance, all this, it's the measurement of this pink. You do have to know the center, and you have to know the radius. Now remember that the radius, the perimeter is circumference is also kind of the perimeter of a circle. Okay, you know that pi is the ratio between the circumference of the circle and the length. You don't. That's something you can tell your kids. Okay, you don't usually find that too often, but it's kind of cool. Okay, do not forget that if this is the radius, the diameter is 2 times the radius, and the circumference is pi times diameter, or 2 pi r. Either one of these formulas work. Okay, now pi is a number. This ratio is that special ratio, and it's a never-ending. It is a never-ending decimal. These are estimates. Okay, even 22/7 is an estimated fraction for pi. Okay, and we can use 3.14. You now have calculators that have pi in it that even the younger kids will use. So just understand that could happen. You might use it. Arc length. Arc length helps me find the measurement, the linear measurement of, let me go a different color here. I'm still in blue. Okay, this distance here. You take this piece and you stretch it out, you can find the distance of that. This length is pi times the radius times theta, which is this measurement of the angle. all divided by 180. Okay? All right, so let's kind of find a few things. So it says the circumference of a circle and the radius is 2 meters. So circumference of the circle, remember that's pi r times 2, or 2d. So this would be 2 pi times 2, which would be 4 pi meters. Okay, the radius of the circle of the circumference is 15 pi. All right, so what do they want us to do here? They want us to take this, okay? They want us to take 15 pi and make it equal to 2 pi r, okay? Now, that's not the best way of writing it, but you get the gist, okay? So divide by that, so you would take 15 divided by, or 15 pi, excuse me, divided by 2 pi. The pi's will cancel, and this should be how many meters that radius is, which 7.5, which is 15.2. Okay. All right. The length of a 25-degree arc of a circle with diameter of 10. Okay. So remember, that's going to be 25. That's your theta, pi over 360. Okay. Now, where did they get that from? Okay. Don't forget. Let's go back. Whoops. Let's go back. The length, pi r theta over 180, right? Okay, so it says the length of this, so that's going to be, the length is L, 10 is equal to pi r radius, whoops, sorry, messed that up. Okay, they're telling me they want the length, so they want L. So let's try that again. So we want L is equal to pi, radius is 5, and the theta is 25, all over 180. And where they get that number from is this 5 goes into 180 36 times. Okay, so the approximate length is this. Now, what is the difference between approximate and exact? This is exact. This is approximate. All right, the radius of an arc whose central angle is 87 degrees, okay, and whose length of the arc is 154. So now in this case, you're taking the 154, you're setting it equal to pi r, which we're trying to find, theta 87, all over 180. Okay. So you're trying to find the radius, okay, of the arc with that central angle. That's a big angle. Okay, the length is 154. So you'd multiply the 180 and divide by 87, and we get 101.4. Okay. So let's see here, I'll let you see that easier. So you get that answer. Okay. And that is the end of this session.